I'm Anil Kumar, and here we will learn how to find composition of a function from the graph, rather evaluate composition of a function from the given graph. Question is, consider the following graph to answer the questions. First one, explain how will you determine the result of g of f of 3, then evaluate, right? So g of f of 3 means what? That means we'll first find what is f of 3, right? So we'll find what is f of 3. Now f of 3 means value of function f. So this straight line represents the function fx. Parabola opening downwards is the function g of x. F of 3 means at 3 x value, what is the value of the function? So it is this value, correct? So f of 3 is for us 2, correct? So we get f of 3 equals to 2. Now when I say g of f of 3, that means g of 2, correct? So that is what we mean. So at 2, let us find the value of function g of x. It's just the parabola. So at 2, it is this point, right? So that is equal to 1. So that is how we find the value, correct? So composite functions can be evaluated from the graph as shown here. Now let's look into the second example. I hope that is clear, right? So let me write the other way also so that you can understand. So what we do here is we say g of f of 3, and we know f of 3 is at 3 the value of the function, which is 2. So it is g of 2, and at 2 we went parabola, actually both are same points, we get 1. So that is how we get our answer. Now part B is it possible to evaluate f of g of 3? That is the question. So here let us find what is g of 3 equals to. Inside function, right? So g of 3 means value of g at 3. So 3 is this, right? So at 3 the value of the function is minus 4. So we have value minus 4. Now when I say f of g of 3, that means we want to find what is f of minus 4, right? Now at minus 4, the value of the function, it does not match, right? So it does not exist. Now the question, is it possible to evaluate f of g of 3? Justify your answer. No, it is not possible. Why it is not possible? That is what you need to answer, right? So what you see here is that the range of g function g of x, right? So we say that the range of g of x is, so we say range of g of x is not in the domain of f of x. Do you see that? So that is why the range, this value minus 4, is not in the domain of f of x. Domain of f of x is from minus 3 to 4. Do you see that? So what you notice here is that the domain of f of x is from minus 3 to 4, right? So, and that value minus 4 is not in the domain of g of x. That is why we cannot find it. So it is important to understand that when you're working on composition of functions, then the composition is only possible if the range of the inside function is within the domain of the outside function, right? So it is kind of like this. You're given the value, these are 3 functions involved, right? So when we are saying f of g of 3, then it means that from here to here, that is the function g, right? Now the range of this becomes the domain of our function f of x. This is what it is. This is f of g. Do you understand? F of g. And this is what we normally represent as f of g of x, combined function. Is that okay? So that is how it is. So range of g of x should be in the domain for the values. If it is not, then you cannot find it. So some could be evaluated, some cannot be evaluated. That is how we figure it out. I hope that's absolutely clear. Thank you and all the best. test.